In lesson 9, we factored expressions by undoing the distributive property a bunch of times for polynomials that had 4 or more terms. If it was a binomial, we're normally looking for GCF, difference of perfect squares and perfect cubes. If it's a trinomial, 3 terms, we're looking for GCF and using the AC method probably. Once you have 4 or more terms, you have to use this idea of grouping and looking for and making use of structure to factor these expressions by undoing the distributive property by GCF factoring a whole bunch. So let's jump in and look at some of these problems. Factor the following polynomials completely. I hope you're not shocked by those directions by now, because that's what we've been working on, is building up our factoring techniques. So I have 4 terms, which clearly means I'm grouping. So I'm going to look at the first 2 terms and group the second 2 terms together. And we're going to GCF. What can I take out from those first 2 terms? I can take out an x squared. And I'm left with x minus 6. Well, over here, I need an x minus 6 to occur. So what do I need to GCF out from those second 2 terms to get that x minus 6? Well, it looks like a negative 25. Negative 25 times x is negative 25x. Negative 25 times negative 6 is positive 150, so that works. Now, I took my 4-term expression and made it into 2 terms. And my new GCF is that x minus 6 factor. So I'm going to factor that out, and I'm left with x squared minus 25. And great, we did the grouping portion, but now you know what to do whenever you see an x squared minus 25, is we're going to rewrite that as the difference of perfect squares as x plus 5, x minus 5. And that's factored completely. In this next example, again, 4 terms, group them. What can I take out from the first 2 terms? Just an x squared, and I'm left with 3x minus 5. Well, I need to somehow end up with a 3x minus 5. And this is where knowing where you want to go is good. Because what times 3 gives me negative 48? What times 5 gives me 80? Well, it looks like I'm going to have to take out a minus 16 there. Minus 16 times 3 is negative 48. Negative 16 times negative 5 is positive 80. So my new GCF is that 3x minus 5 factor. So I'll factor that out, and I'm left with x squared minus 16. But clearly we know what that is. X squared minus 16 is the difference of perfect squares. Done. Not too bad. We've been building up to this lesson, so this lesson should not be too terrible. But it just takes time practicing to get fluent at it. Again, just like always, I see I have 4 terms. I always need to look for a GCF. You could start grouping and take the GCF out at the end, but I like taking the GCF out right away. Everybody has an x that I can take out, so I'm going to get rid of that x. So I took out an x from all the terms. I factored that out. And now I group. I group my first 2 terms and my last 2 terms. I can take out x squared from the first 2, and I'm left with x minus 4. I can need an x minus 4, so what can I take out from those 2? A positive 4. And I'm left with x minus 4 times x squared plus 4. I cannot forget that x. That x comes along for the ride. We just can't get rid of him. Can I factor x squared plus 4? Not right now. It's the sum. I can only factor the difference of perfect squares, so we actually are done here. That's factored completely currently. So what happens if you didn't realize there's a GCF? I'm going to do that in this next example here. Clearly there's a GCF of 2 in all these terms, but I'm going to pretend like I didn't see that. It is okay. You'll just have to do it at the end. So I see those 4 terms. I'm going to group. You should take out the GCF of 2 now, but I'm going to show you what happens if you don't. Well, what can I take out from those 2 terms? A 2x squared. And I'm left with 2x. What times 2x squared is 2x squared? Plus 1. So I need a 2x plus 1 over here. What do I need to factor out? It looks like I need to factor out a minus 18. So I have 2x plus 1 times 2x squared minus 18. So look where that GCF of 2 ended up. It's right in there. I need to GCF out the 2 that I should have done from the beginning. So by pulling out a 2 from that term there, I'm left with x squared minus 9, and we know x squared minus 9 is the difference of perfect squares. So this is factored completely. It's beneficial to take that GCF out right away instead of leaving it in because you might forget to find it. And then you don't finish factoring it completely. Always, always take out your GCF. Number 2, explain why this polynomial cannot be factored using grouping. Well, it's got 4 terms, right? So if I try to group this, okay, well, can I get an x plus 3 here? I would have to put a -2. That works. Oh, that's why I can't put grouping, because there's nothing that's going to go there that gives me an x plus 3. We cannot group. Explain means write a sentence, so I'm writing a sentence, because after we group the terms, we cannot, well, not we cannot, there is no common factor left. There was no common factor of that x plus 3. Well, I could factor out a -2, but I'd be left with x minus 3. These two expressions are equivalent, but look at this. I can't factor out an x plus 3 and an x minus 3. There's no GCF there. So there's no common factor that I can factor out. So that's why we can't use we cannot use grouping. Sorry. We cannot use grouping. Sorry, I'm going too fast here. We cannot use grouping because after we group the terms, there is not a common factor left. Take your time so your sentences don't look like mine did right there. We cannot use grouping because after we group the terms, there is not a common factor left to GCF out. We can even say to GCF out. So just because you see 4 terms does not always mean grouping is going to work. We might have to come up with other strategies on how to factor that. But most of the time it is grouping. But there is chances, not every expression can be factored by grouping, so be careful of that. Number 3, factor these expressions completely. These 3 expressions on this page take a little bit more work, and they're a little bit trickier, but they're absolutely doable by grouping. I've got 4 terms. That's an automatic key to group. Is there any common factors? Not everyone has an x. Not everyone has a y. 6, 5, 24, 20, no. So I'll group the first 2 terms. What can I take out? Just an x squared. I'm left with 6x minus 5y. So I somehow need to end up with 6x minus 5y over here. So what can I GCF out from this second group here? Well, it looks like I'm going to need a -4. Yes. -4 times good. And it looks like I'm taking out a y squared as well. Yes. Good. So my common factor now is 6x minus 5y. And that leaves me with x squared minus 4y squared. But warning, warning, warning. This is the difference of perfect squares. So we get x minus 2y, x plus 2y. That's how we factor that expression completely. So this expression looks different because there's 6 terms, not 4, but we can still use that grouping idea. However, I know it's very, very tempting to rewrite this expression by combining the like terms, by smushing the x squareds together and the x's together. Don't do that. I gave you this problem in this form so that you can apply the grouping method. If I didn't give it to you in this form, grouping will not work, and you're going to have to use some other method that we don't know yet that's not even really an algebraic method. So don't touch it. Leave it as it is. With 6 terms, you have to decide, do I do groups of 2 like we have been, or can I do a group of 3 like 2 groups of 3 or 3 groups of 2? You have to decide. However, here's what's helping me decide. I don't like those x squareds or those x's in the same group. So groups of 3 probably isn't going to work. So let's see groups of 2. Maybe that'll work. So we take out a GCF. What can I take out from that first term? X squared. And I'm left with x minus 3. What can I take out from the next term? Well, I want an x minus 3. That'd be nice. So a -6, -6x, good. A negative 6x I'm going to take out, not just a negative 6, a negative 6x squared. Good. This looks promising, so what do I need to take out? I need an x minus 3. What am I taking out? A positive 8. Don't forget the signs there, just don't put 8, it's a positive 8. So, what's my new GCF? What do all of these terms have in common? They all have an x minus 3. What am I left with? X squared minus 6x plus 8. After you factor out that x minus 3, you're left with that trinomial there, which is not factored completely yet because that trinomial is what multiplies to 8. That adds to negative 6, x minus 4, x minus 2. So factored completely, that expression is equivalent to x minus 3. It's the same as x minus 3 times x minus 4 times x minus 2. So if there's ever 6 terms, it could be 8, could be 9. If there's ever more than 4 terms, don't start smushing them together. See if you can group to factor it. Here's the thing. It's so tempting to combine these like terms here. I know you want to smush those x squareds together, but don't. I gave this problem to you in this form so that you can use the grouping strategy to get them together, to actually factor it, to actually be able to factor it. If you combine them, you will not be able to factor it by hand with grouping. It will be a mess, so leave it alone. Well, there's 6 terms, so I can do groups of 2, or I could do groups of 3. And that's the big decision we need to make. Groups of 2 or groups of 3. Well, here's the thing. If I try to do groups of 2, this gets weird in the middle here. That gets weird in the middle there. So I'm going to try groups of 3. You might have to try something and fail first and switch. Say 3 didn't work, maybe 2. So it is kind of a guessing game, but you'll be able to figure it out. Alrighty. I can take out an x squared from all of those terms, and I'm left with 2x to the 2x squared minus 7x minus 15. So hopefully I'm left with 2x squared minus 7x minus 15 over here. What do I need to factor out to get that to happen? I don't know why I wrote that so far away. Move that a little bit closer. Negative 4, right? Negative 4? Yes, yes, yes. So what's my common factor? Both terms have that trinomial as a common factor, so I'm going to GCF that out, and I'm left with x squared minus 4. Great, you factored it, but it's not factored completely. I see this very quickly, and I say, okay, I got that. But what do we need to do for that trinomial there? The AC method. What multiplies to negative 30 that adds to negative 7? Well, what multiplies to 30? 1 and 30? No. 2 and 15? No. 3 and 10? That looks promising. I could do 3 and 10. 3 and 10, but I need the 10 to be negative. So I'm going to rewrite this. You can even do this on the side over here. 2x squared plus 3x, remember we split that middle term, minus 10x minus 15. So what we do is we make these trinomials into a grouping problem. I'm going to take out an x. We make trinomials using the AC method into a grouping problem. And it factors as x plus 3 times x minus 5. So those are the factors of that expression. There's 4 of them. We had to use grouping, the difference of perfect squares, and then we factored using the AC method. It's a lot of work for one problem. And if you smush those middle terms together, you wouldn't have been able to do it. Leave it alone. Don't mess around. They left it that way for a reason.